Time is the only thing every human has felt, feared, chased, and lost. Yet no one truly understands. It slips through our fingers, dictates our lives, and shapes our memories, but we barely grasp what it actually is. And that's where the mystery begins. Because for the last century, humanity has been asking a question so absurd, so rebellious, so dangerous to the foundations of science that it almost feels forbidden. Is it possible to break time? To bend it? To leave it entirely? Or even return to a moment long gone? For most people, time travel is nothing more than a beautiful dream crafted by cinema. A poetic fantasy explored in films like Interstellar, where gravity becomes a key to the past, or Back to the Future, where a teenager accidentally rewrites his own existence. Donnie Darko uses it to unravel a psychological labyrinth, and Doctor Who treats it as a playground of infinite possibilities. Pop culture didn't just romanticize time travel, it defined how we imagine it. We picture flashing lights, wormholes, paradoxes, and timelines that crumble like dominoes. But what if fiction is only scratching the surface of something far stranger and far more real? Scientists have debated this idea intensely, sometimes dismissing it, sometimes fearing it, and sometimes suggesting it might already be happening. Because the deeper physics goes into the nature of time, the more it exposes cracks in our understanding. Cracks that hint at something weirder than any science fiction story. Some physicists argue that time might not even exist the way we think it does. Others claim that the universe allows the past and future to coexist at all times. Some say time is simply your brain interpreting a sequence of events, nothing more. And then there are theories indicating that traveling to the future is not only possible, but already proven. But before we explore the theories, the paradoxes, and the hundreds of scientific papers, we must confront the question everyone avoids. Why are there so many photos and videos of time travelers circulating online? Why do historical images appear to show modern clothing, modern devices, or people out of place? Why do certain stories sound too detailed or too impossible to be dismissed as mere coincidences? Are they all hoaxes, or is there a pattern we haven't noticed? One of the most iconic examples is the hipster time traveler from the 1940s. A photo taken at the reopening of a bridge in Canada shows a crowd dressed in typical mid-20th century clothing, except for one man. He wears sunglasses that didn't exist at the time, a printed shirt decades ahead of fashion, and what looks like a small, portable camera modern in design. Historians tried to debunk it, and some explanations exist, but none fully satisfy the uncanny feeling the image creates. Is it misinterpretation, or a glitch in time? Then there's the mysterious video of Mike Tyson's 1995 boxing match, where a spectator appears to be filming the fight with a smartphone, more than 10 years before smartphones were invented. Analysts studied the footage frame by frame. Some say it's a camcorder that happens to resemble a phone. Others aren't convinced. Because, again, what is the statistical probability of so many coincidences? Another case that refuses to die on the internet is John Titor, the alleged time traveler from the year 2036 who appeared in online forums in early 2000. His claim? He was a soldier sent back in time to prevent a global catastrophe. Most people considered it a prank. Yet, curiously, several of his predictions were not about events, but about technological developments, some of which decades later turned out eerily accurate. Coincidence? Good guessing? Or something else entirely? And these stories are just the tip of the iceberg. Because long before smartphones and forums, ancient myths and religious texts already described events that today sound suspiciously like temporal anomalies. In the Indian epic Mahabharata, King Kakudmi travels to the realm of Brahma seeking advice. When he returns home, he discovers that hundreds of years have passed. In Japanese folklore, fisherman Urashima Taro spends what feels like a few hours beneath the sea, only to return and find centuries gone. In Celtic mythology, the fairy realms distort time. A single night among them can mean decades in the human world. These aren't just myths. They are the echoes of a universal idea that time is not constant, not stable, not linear. But modern science takes this further. Consider Einstein's theory of relativity. Tells us that time is elastic. It stretches, bends, slows, and accelerates depending on gravity and velocity. Time runs slower on Earth's surface than in orbit. Astronauts age differently than we do. GPS satellites have to constantly adjust their clocks because time is literally passing faster for them. This isn't a thought experiment. This is measured, proven, undeniable. If you move fast enough or approach something with immense gravity, you can travel to the future. Not metaphorically, literally. But here comes the question that movies obsess over. Can we return to the past? The scientific answer is complicated. Some theorists believe wormholes could allow it. Some argue cosmic strings, hypothetical defects in the fabric of spacetime, could act as time machines. Some mathematicians propose that the universe already contains closed time-like curves, loops where past and future collide. But there's a problem, a terrifying one: paradoxes. If you go back in time and change something, what happens to your present? If you stop yourself from being born, who went back in time to do it? If you warn someone of their fate, do you create a new timeline? Or do you simply fulfill a destiny that was always fixed? Physicists don't laugh at paradoxes. They fear them. Because time travel breaks cause and effect, the single rule the universe seems to fight to protect. And yet, the universe might have built-in mechanisms that prevent paradoxes from happening. The Novikov principle suggests that anything a time traveler does was always part of history. In this view, free will collapses. The timeline cannot be broken. But other theories argue the opposite. Any change would split reality into multiple timelines, infinite versions, infinite consequences, and suddenly, we arrive at a disturbing possibility. What if we already live in a modified timeline? What if someone or something changed the past and we simply have no memory of the original version? How would we know? How could we detect an event that erases the memory of its own occurrence? This brings us to the strangest part of all: the recent discoveries shaking the scientific world. Experiments with quantum particles show they can influence the past. The delayed choice experiment reveals outcomes that defy logic. Some physicists even propose retrocausality, the idea that effects can precede their causes. And a handful of recent studies claim time may be emergent, not fundamental. Meaning, time might not be a real dimension. It might be something the brain creates to interpret reality. If time is not fundamental, then breaking it might not break the universe at all. It might simply reveal the truth behind it. For decades, stories of alleged time travelers have circulated like digital folklore. Shared, mocked, debated, and sometimes forgotten. But every once in a while, a case emerges so baffling, so detailed, or so well documented that it refuses to disappear. It clings to the internet like a ghost, surviving countless attempts at debunking. Some are hoaxes, some misunderstandings, but some remain suspended in a realm where logic alone cannot fully explain them. And it's in these stories that the world finds itself torn between skepticism and awe. Take, for example, the story of Andrew Carlson. In 2003, he appeared in a police report leaked to the media. A mysterious man arrested for making 126 perfectly timed stock trades, turning $800 into $350 million in just 2 weeks. When questioned, he allegedly confessed that he was a time traveler from the year 2256. Investigators dismissed the claim immediately, assuming he was mentally unstable. And yet, no records of his existence before that year were ever found. No family, no footprint, no history. After posting bail, he simply vanished. The official explanation is that the story was satire taken out of context. But believers insist that too many details never aligned. The perfect trades, the disappearance, the clean background, a tale too strange to be fully dismissed. Then there's the curious case of the man from Taured. The year was 1954, and Tokyo airport security detained a man carrying a passport from a country that didn't exist. He insisted his homeland, Taured, had existed for 1,000 years and appeared genuinely confused that no one had heard of it. Even stranger, the passport looked authentic, containing visas and stamps matching years of documented travel. Officials placed him in a guarded hotel room overnight while they investigated. By the next morning, he was gone. Vanished from a locked room under surveillance, his documents gone with him. The story has become one of the most famous examples of interdimensional travelers, but others argue it could just as easily be a case of time displacement. After all, if timelines can shift or diverge, what prevents someone from arriving from a version of Earth where borders evolve differently? But perhaps the most unnerving cases are the subtle ones, the ones that hide not in explosive claims but in everyday details. Stories where the witness has nothing to gain, nothing to promote, and everything to lose. Consider the tale of the woman in the library, recorded in a small rural town in the 1980s. A librarian noticed a woman in the back corner reading a newspaper from 1945 as if it were today's news. When approached, the woman looked startled, as though waking from a dream. She asked what year it was. When told, she panicked, dropped the paper, and ran toward the exit, only to vanish the moment she rounded the corner. The librarian described the event in a local newspaper, but it remained unknown to the wider public until the internet revived it decades later. Hoax? Misinterpretation? Or something far stranger? But no case has captured global attention quite like the story of Rudolph Fentz. According to the legend, in 1951, a man appeared in Times Square wearing 19th century clothing, confused and frightened. Moments later, he was struck by a car and killed. When authorities examined his belongings, they found coins from the late 1800s in perfect condition, a letter dated 1876, and a business card from a man no one in modern records could identify. Further investigation revealed that a man named Rudolph Fentz had indeed disappeared without a trace in 1876. Skeptics claim the entire story originated from a work of fiction and spread like wildfire, yet believers argue that too many reports predate the alleged fictional source. The truth remains murky, tangled in contradictions and missing documents. And then we have the most unsettling category of all: time travelers who left behind not stories, but impossible technology. Devices centuries ahead of their era. Artifacts that defy explanation. In 2010, archaeologists working at a Chinese tomb uncovered a tiny artifact shaped like a wristwatch, complete with hands frozen at 10:06. Embedded in the stone, sealed in a coffin undisturbed for 400 years, the miniature watch sparked global fascination. Critics argued it was a modern object accidentally dropped during excavation, but supporters countered that the tomb had been sealed since the Ming Dynasty. Was it a mistake in documentation? A mix-up in the press release? Or an object out of time? These cases may be anecdotal, unverified, exaggerated, or misunderstood, but their collective weight reveals something important. Humanity is obsessed with the idea that time is not as rigid as it appears. We want to believe someone has broken the rules. We want to believe the universe has a loophole. And perhaps that desire comes from something deeper than curiosity. A longing, a wound, a wish to undo mistakes, to revisit memories, to save someone, to relive a moment of joy. Time travel is not just science fiction, it is emotional fiction, a fantasy rooted in regret and hope. But science does not deal in hope. It deals in evidence. And the evidence for time travel in the modern era doesn't lie in old photos or strange stories. It lies in the physics that govern the universe itself. Because while popular culture shows time travel as a mechanical, dramatic, explosive event, scientists view it as a subtle, mathematical, almost elegant possibility. To understand how, we must first understand what time actually is. Most people imagine time as a line, past behind us, future ahead. But physics treats time as a dimension intertwined with space. A four-dimensional fabric called space-time. Objects don't move through space alone, they move through time as well. And that motion can be manipulated. Gravity bends time. Velocity stretches it. Acceleration slows it. This is not science fiction, it is measured reality. Consider this. If you could travel at 99.999% of the speed of light for what feels like a single year, decades, or even centuries would pass on Earth, you would return younger than everyone you knew. This is not a hypothetical. This is a direct consequence of special relativity, confirmed by particle physics experiments and atomic clock measurements. In a very real sense, Astronauts aboard the International Space Station are time travelers, aging slightly slower than the rest of us. But what about traveling to the past? This is where things become dangerously complicated. According to general relativity, if the universe contains rotating black holes, called Kerr black holes, they could theoretically create pathways that lead to past regions of spacetime. Wormholes, if they exist and could be stabilized, might allow for the same. Even certain cosmic structures known as closed time-like curves appear in mathematical models of the universe. These loops allow an object to return to its own past. The problem? Nature seems to resist them. Quantum mechanics introduces chaos. Wormholes collapse. Exotic matter is required, matter with negative energy density, something we have never observed on a usable scale. And then the paradoxes appear, threatening to unravel logic itself. If you prevent your grandparents from meeting, what happens to you? If you send information to your past self, where did the information originally come from? These loops create what scientists call causal violations, and some believe the universe forbids them, yet not everyone agrees. The many worlds interpretation of quantum mechanics suggests that every choice, every event, every possibility branches into a new timeline. In that framework, paradoxes don't exist because changing the past simply creates a new universe. A time traveler could visit a version of ancient Rome, alter it dramatically, and return to their own timeline unaffected. They wouldn't be rewriting their history, only branching into another. This raises a disturbing question. If time travel creates new timelines, could we already be living in one created by someone else? If a traveler altered something centuries ago, we would have no way to know. Our history would simply be ours, clean, unbroken, a timeline born from interference we cannot detect. And then there's the most radical idea of all. That time does not exist. Some physicists argue that time is not a fundamental aspect of the universe but an emergent property, something that arises only because humans perceive change. In this view, the past and future are illusions. Everything exists simultaneously. Every moment, every event, every possibility, all at once. If this is true, then time travel is not about moving through time. It is about navigating a landscape of static moments. If all moments exist, then visiting another moment is not impossible. It is simply a matter of finding the right path. If popular culture is responsible for fueling our imagination about time travel, then modern physics is responsible for reminding us just how strange our universe truly is. Because every decade, new discoveries emerge that challenge our assumptions about time, reality, and the limits of what humans can understand. And perhaps the most unsettling part? The more we learn, the more it seems like time itself is far less stable than we once believed. To grasp this, we need to begin with a simple yet profound truth. Time moves differently depending on where you are and how fast you're going. This isn't a theory anymore. It's a measurable phenomenon. Atomic clocks placed at different altitudes tick at different speeds. The Earth's gravity stretches time itself. Even your head ages slightly faster than your feet. These differences are tiny fractions of nanoseconds, but they prove something extraordinary. Time is flexible. It bends. It warps. It stretches. Compresses. And once you accept that time is not rigid, everything else becomes possible. At least in theory. One of the most shocking ideas in physics comes from Albert Einstein's general relativity. The notion that massive objects don't just influence space, they distort time. Imagine space-time as a vast, four-dimensional ocean. Planets, stars, and galaxies create waves and ripples that shape the flow of time around them. The stronger the gravity, the slower time moves. A clock near a black hole ticks slower than a clock in deep space. This means that, under the right conditions, one could travel into the future simply by positioning themselves near an extreme gravitational field. You wouldn't be breaking the laws of physics. You'd be using them. But traveling backward? That's where things become far more difficult and far more controversial. Some of the most elaborate solutions arise from hypothetical cosmic structures known as wormholes. A wormhole can be thought of as a shortcut through space-time, a tunnel connecting two distant points. They appear naturally in certain equations, but they require negative energy to remain open, something we do not yet know how to produce. If stable wormholes existed, one end could be accelerated to near light speed and then brought back. Time dilation would cause one end to age slower than the other. Step through one side, and you'd emerge from the other at an earlier point in time. It sounds impossible, yet the math allows it. Other physicists propose rotating universes or enormous cosmic strings, infinitely long, ultra-dense relics from the early universe that could wrap space-time around themselves, creating loops in which a traveler could revisit the past. Even the existence of quantum entanglement, where particles mirror each other's behavior instantaneously across vast distances, hints at a universe where time might not flow in a strictly linear way. And then there are the paradoxes, the logical nightmares that haunt every theory of backward travel. If you go back and prevent an event that led to your time travel, how do you travel in the first place? If a scientist meets their future self and learns a breakthrough formula, who invented it? These circular problems seem to violate cause and effect, one of the bedrocks of reality. Yet physics may have a solution, the Novikov self-consistency principle. According to this idea, the universe prohibits paradoxes by ensuring that anything a time traveler does was always part of history. You cannot change the past. Your actions were already woven into it. If you attempt to prevent something, your intervention will cause the very event you sought to stop. The universe, in this view, is self-correcting, a closed, unbreakable loop. But even this principle has limitations. Many scientists argue that paradoxes are not only possible, they are unavoidable. And if paradoxes exist, then the universe must allow alternative timelines. This concept forms the foundation of the many worlds interpretation. Every decision creates a branching universe. Every possibility is realized somewhere. Under this framework, time travel does not rewrite the past. It creates a new one. Step backward, make a change, and you've simply created a parallel world. Your original timeline remains intact. This raises profound questions. If infinite timelines exist, how many include civilizations far more advanced than our own? How many have already mastered time manipulation? And could travelers from those universes be mistaken for visitors from our future? The strange part is that modern research increasingly supports the idea that parallel universes might be more than fiction. Certain anomalies in cosmic background radiation, mathematical models that predict multiverse structures, experiments in quantum computing that behave as if multiple states are interacting simultaneously. None prove the multiverse, but none rule it out either. But before diving deeper into alternate timelines, we must address a far more immediate reality: that the universe behaves in ways no one anticipated. Consider black holes. Once thought to be cosmic monsters that devour everything, they are now understood to be one of the most fascinating laboratories for time manipulation. The closer you approach a black hole, the slower time flows. Stay near the event horizon for what feels like hours, return to Earth, and you could find centuries have passed. There is no speculation here. This is a direct consequence of relativity. A natural time machine, albeit one that no human could survive. Then there is the possibility that the universe itself is a simulation. A theory once dismissed as fringe but now studied seriously by physicists, philosophers, and computer scientists. If the universe is a simulation, then time might not be fundamental, it could be a software parameter. Something adjustable. Something that could be paused, rewound, or altered under the right conditions. This perspective reframes time travel not as breaking the laws of physics, but as modifying the rules of a system. In fact, recent theoretical work suggests that quantum systems may not experience time in the same way humans do. Particles can exist in superpositions, multiple states at once. Some equations imply they can exist in superpositions of different times as well, meaning a particle can be in before and after simultaneously. To us, this is incomprehensible, but in quantum reality, it is normal. All of this brings us back to a simple truth. We still don't know what time is. Every scientific breakthrough answers one question and opens 5 more. Time behaves like a dimension, but also like a field. It flows forward, but can be mathematically reversed. It is universal yet subjective, physical yet psychological. Even in human experience, time is slippery. It slows during fear, It accelerates during joy. It distorts in memory, trauma, dreams, and deep meditation. Neuroscientists have found that the brain constructs the feeling of time by stitching together sensory input. When the stitching pattern changes, so does our perception of the flow. This raises a stunning question. If our experience of time is manufactured internally, then how much of our reality is shaped not by the universe, but by the machinery inside our minds? This is why researchers studying déjà vu and temporal illusions have become increasingly important in discussions about time travel. Déjà vu, that eerie sensation of reliving a moment, might be a neurological misfire or something far stranger. Some scientists argue that déjà vu could hint at the brain cross-referencing parallel timeline data. Others suggest that near-death experiences, with their time dilation, might reveal how the brain decouples from ordinary temporal flow. Even dreams, where hours pass in seconds and seconds stretch into eternity, challenge our intuition about time's rigidity. The more we observe, the clearer it becomes that time is not a single phenomenon. It is a tapestry, woven from physics, consciousness, perception, and cosmology. A structure far more mysterious than the ticking of a clock. Which brings us to a chilling possibility. If time is flexible, nonlinear, and perhaps even illusory, then what we perceive as the present may not be the whole picture. The universe may contain layers of reality we cannot access. Perhaps the past still exists. Perhaps the future is already written. Perhaps time travelers, if they exist, do not move through time, they simply shift their point of observation. And if that is true, then the question is no longer whether time travel is possible. The question becomes, would we even recognize a time traveler if we saw one? People often picture time travel as a dramatic leap through a glowing portal or a jump into a machine filled with spinning lights and humming coils. But if there is even a small chance that time travel is possible, the real path to it would probably look nothing like the movies. It would come from equations, experiments, and strange anomalies at the edges of physics, places where the universe behaves in ways most people never imagine. Some researchers believe that if the key to time travel exists, it's hidden not in futuristic technology, but in the fundamental nature of reality itself. And this is where the conversation takes a sharp turn away from fiction and directly into the frontier of modern science. One of the most intriguing ideas comes from the concept of retrocausality, the possibility that the future might influence the past. It sounds impossible, almost philosophical, but this idea appears unexpectedly in some quantum experiments, especially in scenarios involving entanglement. In certain tests, particles separated by large distances behave as if they share information instantly, faster than the speed of light. Physicists call this non-locality, and even Einstein was disturbed by it, referring to it as spooky action at a distance. The unsettling part is that quantum measurements made now can appear to determine outcomes that were set before the measurement occurred. Does that mean the future is reaching back into the past? Most scientists would say no, insisting that it's simply a strange statistical effect. But a minority argue that retrocausality, if someday proven, could provide the first scientific foundation for a form of time travel, one based on information rather than bodies moving between eras. Beyond that, there is the bizarre idea proposed by the many worlds interpretation of quantum mechanics. According to this perspective, every decision, every random event, every quantum fluctuation splits reality into multiple versions of itself. Infinite timelines branching endlessly from every moment. If this is true, then time travel might not mean changing the past. Instead, it would mean entering a different version of it, one of countless timelines where things played out differently. A traveler would not alter their original reality but move into a new branch where different decisions were made, different outcomes occurred, and different futures formed. It sounds like science fiction, yet many physicists consider this interpretation a valid explanation of the quantum world. The real question is whether a human could ever access those branches or move between them. If such a mechanism exists, it is far beyond anything modern technology can create. But time itself might not be as rigid as we think. According to Einstein's general theory of relativity, time slows down in the presence of strong gravity. This is not theoretical, it's measurable. Astronauts aboard the International Space Station age slightly slower than people on Earth due to both velocity and gravity. GPS satellites must be corrected daily because their clocks run differently from clocks on the ground. The closer you are to a massive object, the slower time moves. If someone were to orbit extremely close to a black hole, though they would need impossible levels of protection, their time would slow down dramatically compared to someone far away from it. In that sense, they would travel into the future. Hours for them could be years for someone else. This is real physics, not speculation. What remains uncertain is whether the opposite is possible, traveling into the past. Relativity does allow for closed time-like curves, strange loops in space-time that could theoretically let someone return to an earlier point. These curves appear in solutions involving rotating black holes, wormholes, and cosmic strings. But just because the math permits them doesn't mean nature allows them to exist. It may be that the universe has built-in safeguards to prevent paradoxes, a kind of cosmic firewall that blocks any attempt to tamper with time. Some scientists call this the chronology protection conjecture, the idea that the laws of physics forbid backward time travel to preserve causality. Yet others argue that paradoxes may not be problems at all, as long as reality is more flexible than we assume. Paradoxes are often used to dismiss time travel, but what if the universe is structured in a way that eliminates paradoxes automatically? One hypothesis suggests that if you traveled back in time, you could only act in ways that are already part of history. Your presence would not change the timeline, it would fulfill it. This is known as the self-consistency principle. If true, you could visit the past, but you would never be able to alter it. Your actions would already be woven into the fabric of the timeline you came from, even if you never realized it. You would be part of history, not a threat to it. Another possibility is that paradoxes don't occur because time doesn't work the way we perceive it. We tend to imagine time flowing forward like a river, with past, present, and future clearly separated. But physics suggests that time might be something more like a landscape, where all moments coexist, and our consciousness moves through them. In this model, the past still exists, the future already exists, and the present is only a subjective point of awareness. If this interpretation is correct, the idea of traveling to another moment becomes less like breaking the rules and more like navigating a very complex terrain. Then there are the mysterious cases that continue to fuel speculation. Photographs of people wearing clothing that seems too modern for their era. Videos of alleged time travelers caught on surveillance cameras. Stories of individuals who claim to have woken up in versions of the world that are slightly different from the one they remember. Most of these claims can be explained rationally: coincidences, misunderstandings, hoaxes, or altered memories. Yet there is always a tiny portion that resists clear explanation. These cases sit at the edge of credibility, intriguing enough to spark debate but not solid enough to be called evidence. History itself is full of tales that resemble time travel long before the concept existed in science fiction. Ancient myths from cultures around the world describe individuals who left for what felt like a short journey, only to return and find that decades or centuries had passed. Folktales describe people visiting strange worlds where time flows differently. Some religious texts describe visions of events that occur far in the future. Were these simply metaphors, allegories, or creative storytelling? Or were they early attempts to describe experiences that didn't fit within the cultural understanding of their time? Even today, scientists continue discovering phenomena that challenge our assumptions about time. Experiments with subatomic particles reveal that time may not move the same way at extremely small scales. Research in quantum gravity attempts to merge general relativity with quantum mechanics, suggesting that time might not be a fundamental property of the universe at all. Instead, it may be something that emerges only under certain conditions, the same way temperature emerges from the movement of atoms. If time is emergent, then manipulating it might someday become possible, even if we don't yet understand how. Some theorists propose that time travel might require exotic forms of matter, substances with negative energy or negative mass. These are not known to exist naturally, but tiny amounts of negative energy do appear in certain quantum fields. If we could learn to control them, they might allow the creation of stable wormholes or other spacetime structures that could permit time travel. At the moment, this is firmly in the realm of speculation, but so was nuclear energy, spaceflight, and quantum computing before the right discoveries were made. Ultimately, time travel remains one of the greatest mysteries of science. It forces us to question everything we know about reality, free will, destiny, and the nature of the universe. The truth is that we don't fully understand time, not yet. What we call the past might not be as distant as we imagine. What we call the future might already exist, waiting for us to reach it. And the line between science and science fiction grows thinner every year as new discoveries push the boundaries of what is possible. Whether time travel is achievable or forever beyond our reach, it continues to challenge the imagination, inspire debate, and remind us how little we truly know about the world we live in. In the final stretch of this journey through the mysteries of time travel, we reach a point where science, philosophy, belief, and imagination collide. After exploring theories from Einstein, strange quantum experiments, ancient legends, paradoxes, and modern claims of travelers displaced in time, there's one truth that becomes impossible to ignore. Humanity has always been obsessed with escaping the boundaries of the present moment. We fear time, we chase time, we try to control time, and yet it slips through our fingers no matter how tightly we hold on. That alone may explain why stories of time travel continue to fascinate across generations. They speak to something universal in the human experience: the desire to rewrite mistakes, revisit moments of happiness, and glimpse what the future holds. But if we strip away fiction, emotions, and wishful thinking, what remains? Is time travel real, possible, or destined to remain an unreachable dream? As scientists study the nature of time more deeply, one conclusion becomes increasingly clear. Time is far stranger and more complex than our daily lives suggest. It is not the simple, steady flow we perceive. Instead, it shifts, bends, stretches, and breaks under certain conditions. In extreme environments, near black holes, in the earliest moments after the Big Bang, or at the quantum level, time behaves less like a straight line and more like a flexible dimension. And if time is flexible, then the door to time travel may not be entirely closed. One of the most important ideas to understand is that traveling into the future is not only theoretically possible. It has already been demonstrated on small scales. Astronauts who orbit Earth experience time more slowly than people on the ground. Their clocks tick differently, their bodies age fractionally less. On Earth, this difference is tiny milliseconds, but it proves that time is not absolute. If someone traveled close to the speed of light or near a massive object like a black hole, the effect would be dramatic. They could return to Earth having aged only a few days while decades passed for everyone else. This kind of time travel requires incredible technology and comes with enormous dangers, but it does not violate any laws of physics. It is real, measurable, and consistent with general relativity. The real challenge lies in the opposite direction, moving backward. This is where controversy erupts, where scientists disagree fiercely, where the line between possibility and impossibility becomes razor-thin. Some argue that traveling into the past is forbidden by the universe, that natural mechanisms prevent paradoxes by destroying or destabilizing any structure that would allow backward travel. Others argue the opposite, that the universe might allow it but only under strict conditions, such as self-consistency, where every action a traveler takes was already part of history. And still others believe that traveling into the past might not mean returning to your own timeline at all, but entering a parallel or branching universe, leaving the original unchanged. All of these models share one fundamental implication. If time travel is possible, it would not look like the simple versions we see in movies. It would be complicated, constrained, and likely accessible only through forms that do not yet exist. It might involve wormholes stabilized by exotic matter, rotating black holes, quantum bridges between timelines, unknown particles, or principles not yet discovered. It might allow the transfer of information before the transfer of people. It might require technology so advanced that it appears supernatural. Or it might be something completely unexpected, something that does not fit into any current theory. But even if time travel is theoretically possible, would we ever be able to achieve it? Technology evolves at a rapid pace, but some barriers seem monumental. Creating or manipulating the gravitational power of a black hole would require resources beyond anything humanity can currently produce. Building a wormhole would require a material that bends space in ways we have never observed. And controlling quantum states at the scale of a human body seems nearly impossible with current methods. Yet history reminds us that impossibility is often temporary. Countless inventions once seemed unachievable. Flying machines, electricity, instantaneous communication, nuclear power, and computers that fit in a pocket. Every leap forward in human history began with a moment when someone dared to imagine something beyond reach. Time travel occupies that same space in the imagination. Unrealistic today may be realistic tomorrow. The limit is not just technology but knowledge. We do not yet understand what time really is. Some theories suggest it's not a fundamental property of the universe at all but an emergent phenomenon. If that's true, then learning to manipulate time might be like learning to manipulate temperature or pressure. But to do that, we first need a deeper understanding of the fabric of reality. Quantum gravity, string theory, loop theory, and other cutting-edge ideas all attempt to merge the rules of the very large with the rules of the very small. When that happens, when a unified theory of physics finally emerges, our understanding of time could shift dramatically. But the fascination with time travel is not driven purely by science. There is also an emotional dimension. People want to believe in time travel because it offers hope. Hope for second chances. Hope for answers. Hope that the mistakes of history could be corrected or the tragedies of our lives reversed. It also offers wonder, the idea that future civilizations might visit us, or that we ourselves might one day walk through ancient worlds. This emotional pull is powerful, and it ensures that the idea of time travel will never disappear, even if the science struggles to catch up. And then there are the mysteries, the strange stories that refuse to fade. Cases where individuals seem to appear out of nowhere, claiming to be from another era. Unexplained objects found in archaeological layers where they shouldn't exist. Photographs and videos that seem to show people dressed too modern for their time. Most of these can be explained by coincidence or trickery, but not all. A few remain unsolved, lingering on the edges of credibility, nudging the imagination. Are these anomalies proof of time travel? Probably not, but they are reminders that the universe still holds secrets, and not everything fits neatly into our scientific models. One of the biggest unresolved questions in all of this is simple. If time travel is possible, where are the time travelers? Why haven't they announced themselves? Why hasn't history been overrun with visitors from the future? Several explanations have been suggested. Perhaps time travel into the past is impossible. Perhaps travelers avoid creating paradoxes by hiding their presence. Perhaps they blend in so well we never notice them. Perhaps they only observe. Or perhaps time travel will be invented far in the future, but the technology only allows travel back to the moment it was first created, meaning no one could come to our present because the doorway hasn't been built yet. It's an elegant idea, one that fits both the physics and the mystery. In the end, the question of time travel reveals something profound about humanity. We are explorers by nature. We look to the stars and imagine new worlds. We look to the past and wonder how things might have been. We look to the future hoping it will be better. Time travel captures all of those desires at once. Whether or not it becomes a reality, the fascination itself says something meaningful about us. It shows that we are not content with the present. We want to understand the whole story, from beginning to end. If time travel is ever achieved, it will likely come from a place of science, not fantasy. It will require breakthroughs that reshape our understanding of the universe. It will require courage to test ideas that seem impossible. And it will require imagination because nothing great is achieved without it. Until then, the mystery remains alive, growing with every new discovery in physics, every unexplained anomaly, every ancient myth that sounds a little too familiar, and every human being who dreams of stepping beyond the limits of time. And if you've enjoyed exploring this journey, this blend of science, history, mystery, and imagination, then don't forget to support the channel. Like the video, leave a comment with the time travel question you find most fascinating, and subscribe so you never miss the next deep dive into the unknown. Your support helps bring more stories like this to life. The universe is full of secrets, and together, we'll keep searching for the answers.